The next set of formulas that we're going to discuss in this section is the cofunction identities. So notice that here we have a sine theta on the left, cosine on the right, tangent, cotangent, secant, cosecant. Same here, cosine, sine, cotangent, tangent, cosecant, secant. And there's equal sign, but how can we change one to another? Well, in the argument, notice it's pi over 2 minus theta. So when you substitute pi over 2 minus theta in the argument, the function is going to be changed to a cofunction. So that's how you can remember it. So let's apply it. Example number 7. Write tangent pi over 9 in terms of its cofunction. Well, that's pretty straightforward. If we want to change the tangent to a cotangent, then we're gonna what we're gonna need, we're gonna do pi over 2 minus pi over 9. Okay, and simplify it. So the common denominator is 18. So we have 9 pi over 18 minus 2 pi over 18. That gives us the cotangent of 9 minus 2 is 7. 7 pi over 18. And that's our answer to this question. And before we proceed to our next example, I just wanted to spend a little bit more time on these identities and justify why we see what we see. Okay, so if we have right triangle, and let's say we have this angle alpha, so what would be the opposite angle measure? Well, we know that the total sum of all the angles is 180. If one of them is 90, then we have 90 left for alpha and beta, right? So beta must be 90 minus whatever alpha is, or pi over 2 minus alpha, right? Now, what is, well, let's label also. Label the sides. We have C, A, and B. So what is sine of alpha? Sine of alpha is opposite over hypotenuse, right? So A over C. But what's the and what's A over C for beta? Well, that's going to be adjacent to the hypotenuse, right? So that's actually the cosine of beta. So sine of alpha is going to be cosine of beta just by looking at this triangle. And what's beta? It's 90 minus alpha. And so that same logic is applied to every one of those functions. And that's how we come up with those cofunction identities. Now let's take a look at example 8. And here we're told to verify the identity, and we have our sum and difference of angles. Okay, so I think our left side is more complicated. Plus, just looking at it, I already know which formulas to apply. So I'm just going to take that left side and apply the formulas that we just learned in this section, namely the sine of sum of angles and the sine of difference of angles. So I'm going to start with the left side. And apply my formulas. So I have my sine alpha plus beta. This is what it is. And I also have my sine of alpha minus beta. this is where it is. Okay, so now I notice that I have the same term with opposite signs, and that term those two terms cancel each other. So what I'm left with is sine alpha cosine beta plus sine alpha cosine beta, which is basically 2 times sine alpha cosine beta, which is exactly my right-hand side of the identity. So this identity is proven. Let's try one more. This is example 9, and I have my left side and the right side, and I think the left side is more complex, so I'm gonna start there. So that's my left side. Now I notice the right side, I have tangent alpha and tangent beta. So that kind of gives me a direction in which to trend. So I don't have alpha plus beta or alpha minus beta on the right side. It's just alpha and just beta by themselves. So that gives me a hint that I need to basically write the sign of the difference in terms of just in terms of just alpha and just beta. So I'm going to apply the formulas that we just learned to expand the sign of alpha minus beta. So here it is. I just directly applied my formula for sine alpha minus beta. And that's what I got. I also see that I will be able to cancel out cosine beta and cosine alpha. But first, I have to separate this one fraction into 2 fractions. So I do like addition of fraction but backwards. Separate them into 2 fractions with the same denominator. And now I can cancel out. So now I can cancel out cosine beta, and then cosine alpha. What do I have left? Well, this obviously is tangent alpha, and this is tangent beta. And that exactly equals to the right side of my identity. So yes, it is an identity. We proved it. And as usual, I would like you to try one by yourself. Verify identity tangent of pi minus theta equals negative tangent theta. Try and do this one by yourself. Pause this recording if you have to. And we're going to continue to example 10. And the last problem in this video is going to be example 10. And it's this example is kind of different. It's not as straightforward as the examples that we've seen so far in this section. It reads, let L1 and L2 denote 2 non-vertical intersecting lines, and let theta denote the acute angle between L1 and L2. see the picture. Show that tangent theta is m2 minus m1, where m is the slope of line. M2 is the slope of line 2, and m1 is slope of line 1, divided by 1 plus the product of m1 and m2. All right, so take a look at this picture, copy it if you like, and I'm going to switch to my paper copy. Well, first of all, guys, I want to remind you the connection between the tangent and the slope of the line. Let's say we have a line that goes through the center of the unit circle like that. We're going to call it line K. Well, the point that this line forms when it crosses the circumference of a circle has basically coordinates x and y, which are sine and cosine, right? Now remember that the slope of line K is going to be the rise, which is y, divided by the run, which is x value. And what is that? Y divided by x? Yes, that's going to be a tangent of that angle theta. So basically tangent and the slope of the line, the same thing, tangent equals the slope of the line that forms that tangent, that angle theta. All right, so we're gonna use it here in this problem. Now, in order to tackle this problem, I'm gonna draw additional line. I'm gonna draw a line parallel to x that goes through the intersection of L1 and L2. So that's gonna be our helping line. Next, I want to point out that our angle theta is right here. That's the theta that we're looking a tangent of. Okay. Also, since these lines are parallel, then this angle is the same as, say it's, oh, sorry, this angle right here is the same as angle theta 1. Theta 1. Now, this angle that I marked at the beginning is our theta 2. Theta 2. So our angle theta basically is the difference between theta 2 minus theta 1. So theta is theta 2 minus theta 1. So from here, we can conclude that tangent of theta is going to be the tangent of theta 2 minus theta 1. All right, and let's actually continue here. So tangent theta is tangent of theta 2 minus theta 1. Let's apply our tangent of the difference of angles formula to write it out. And that's going to be equal tangent of theta 2 minus tangent of theta 1 divided by 1 minus tangent of theta 2 multiplied by tangent of theta 1. Okay, but remember here we mentioned that tangent is the same as the slope of the line. So basically we have the slope of line 2 minus the slope of line 1 divided by 1 minus and the product of those slopes. So that's what they asked us to prove. This is it for this video, and I'll see you in the next one.